All right. So let's. So okay. Stop. Matthew, ready? Okay. This. Yeah. Right. I was just gonna say we haven't talked yet about independent and dependent variables. The independent thing is the thing that you plug in, and the dependent thing is the thing that you get back. Okay? What's that? Right. Right. Input and an output. Right. So independent is the input, and dependent is the output. So, for example, if you're buying apples, okay, what they do is you go to the cash register or the checkout, right? And they input into the computer how much your apples weigh. And then what you get back as an output is how much the apples cost, okay? So in that case, the weight of the apples would be the independent variable, because that's what you put in. And then the dependent variable would be the price. Yep, right, good. And so in math, the way this shows up is that the independent is like the x, and the dependent is like the y, okay? All right, so number one, which one would be the independent variable and which one would be the dependent variable, a person's name or their social security number?
Well, I can tell you mine.
Dylan?
It's
Hold them. Yeah. You don't have it? Okay. All right, so this is a weird one, and this is always a little bit of a hard discussion to have with students because it seems like you can always twist this around and make it seem like one thing depends on the other. Yeah. Oh, fourth period, the bigger pile, the second stack with Sophie. So a person's name versus their social security number. I mean, you can do that either way, kind of, right? And I think that's why the second one is the same thing, but it's flipped around, a person's social security number versus their name. So like you could go to a computer, not that I have, but the government has, and you could type in their name, and then it will tell you the social security number. So in that case, the name would be the input or the independent variable, and the social security number would be the output. Or I'm sure you can go the other way around, type in a social security number, and it will tell you the name. So I would say in this case, a person's name versus their social security number, the name is the independent variable because it comes first, and the social security number is the dependent variable. Yeah, would you mind doing that just on an index card? Also, maybe your birth date, um, your current address, and maybe like what your what your best friend your first name of your first pet. Yeah, just kind of mother's maiden name, just or some random stuff like that. Yeah. Oh, I didn't make the key. Did she do it wrong? Okay. And then the next question is that a function? So like, is there a formula that if you tell someone your name, then they like you could figure out sort of like you were saying with add 5, subtract 5, but like if you tell someone your name, could they just use math to figure out what your social security number is? No. So this is not, oh no, that's not what I'm supposed to be thinking of at all. Sorry. I'm sorry. A function means,
I know everyone in Washington has like the first three digits of their social security number.
a function means every time you put in the same input, you get the same output. No. A function means when you put in the same input, you'll never get two different outputs. Okay? So I feel like in this one, you could have two people that have the same name, right? And so you could type in Edward, William, Joseph, and there could be like 5 of them, so you would get like 5 different social security numbers. Does that kind of make sense? And so that means that this would not be a function. This is not, okay. Then if the fingerprints are the input and the person's name is the output, then that's a great example that would be a function. Because supposedly, I don't know if this is an urban legend or not, but everybody's fingerprints are different, right? So if you put those into the FBI database or whatever, then you're only going to get one person back, okay? Okay, now if you flip this around, and so you make the social security number the input, and you make the name be the output. So in this case, you're going to, put in a social security number and get a name back. That is a function, right? Because if you put in one social security number, you're never going to get more than one person with the same social security number. Does that make sense? You have more than one person with the same name, but you never have more than one person with the same social security number. So this would be a function. That felt like a confusing time or way to start that, but that's okay. Okay, the cost of gas versus the amount of gas pumped. Which one is the input and which is the output? Right, the gas is the input, just sort of like the apples. The gas is the independent or the input. And the cost is the output. Okay, now this is where we're going to get a little tricky, and if Matthew had a little more energy, he seems a little down today, he might fight with me, or maybe Nathan will play that role today. Every time you say, I'm going to buy 10 gallons of gas, is the cost always the same, or is it different? It's different, right, depending on the gas station, so you kind of look at that in different ways. If you're at the same gas station, it's always going to be the same. I mean, not like every day, but like...
Dylan said you could just pump it and
But that doesn't mean that the cost isn't... I mean, there is a... Well, you're thinking of cost in a different way than I am. You're thinking of cost as how much you actually pay. I'm thinking of cost as like what it costs. Like the... There you go, good. I knew you were going to snap out of it and start twisting things around on me like that. Yeah. Okay, so you guys want to say this is not a function because depending on the gas station, the same amount of gas could cost a different amount. Then what would make it a function is if every time you pumped 10 gallons of gas, it always costs the same amount. Are we what? Yeah, why? Oh, good call. Usually it's a good idea. It's not homework, but Weston's idea was... No, it wasn't 5. No, it wasn't. Okay, that's not approved. That's not approved. Okay, what are the inputs in this case? Right, the x's. And what are the x's? 3, 4, and 8. And what are the outputs? 6, 10, and 12. Okay, so for this to be a function, every time I put in 3, I have to get 6. And every time I put in 4, I have to get 10. And every time, bless you, I put in 8, I have to get 12. And since nothing different ever happens, this is a function if there was another point in this set that was something like, no, it'd have to be a repeat of one of these. So if it was like 3, 7, then you'd be like, wait, this time I put in 3 and I got a 6, and then this time I put in 3 and I got a 7. That doesn't make any sense. Make up your mind, yeah. So then it would not be a function. Does that make sense? But since that never happens, since you're always getting, as far as we know anyway, we never doubled up, but as far as we know, every time we put in an 8, we're getting a 12. So it's all good, okay? All right, the temperature in degrees Fahrenheit with respect to the time of day. What's the input and what's the output?
Input
Is what?
temperature in degrees Fahrenheit.
The temperature is the output. So the input is the time of day. Yeah, usually when you're dealing with time, that's independent variable. It goes on the x-axis. And then the temperature is the dependent. Okay. Function, yes or no? Yes? Yeah. Because there's only one temperature that goes with each time, right? But then it's a different time. So if the time changes, then the temperature changes, that's okay. But the next day is a different time. Right? I mean, today is like 1:30 or whatever. Right, but then tomorrow is a different time. So that is a function. All right, next one. What are the inputs? The distances or the days? The distance, because it's in the x column. So distance here is going to be the input, and the days is going to be the output. Function, yes or no? No arguing this time.
No.
No. Why not? Okay, good. Right. Right, good. So here when x was 6, then the number of days was 2. And here when x is 6, the number of days is 5. So since we put the same input in and got 2 different outputs, that means it is not a function, right? 200 each time. Wow, nice job. That's really a lot. Okay, next one. The area of a circle as it relates to the radius. What do you input first? What are you usually given first? What? Yeah, the radius. So the radius is the independent. And the area is the dependent. Because you figure out the circle's area by knowing what the radius is, yeah. Yeah, okay. 13,000. Correct, yeah. Function, yes or no? Can you put the same radius twice and get a circle with a different area? No. So that means this has to be function. Okay? No, I'm not a big fan of this independent and dependent variable stuff because of what Matthew and Nathan are doing to me. You can twist it around and say, oh, well, if you give them the money first and then buy the gas, then it switches it. And you're right. And so that's why, I mean, it's fine when you keep it in like math, but then they always try and make it into real world stuff, and then you can always sort of twist it around. Okay, what were the inputs here? 3, 5, and 7. And the outputs are, they're not 5, 5, and 9. They're not 5, 5, and 9. The outputs are 5 and 9. Why would you say 5 twice? That's like saying, you know, what color socks do you have in your drawer? I've got brown socks, I've got brown socks, I've got brown socks, I've got what? Just tell me you got some brown socks and some black socks. You have to list every single one.
Run a function.
It is a function. So this one is here specifically to teach you the distinction between the inputs being the same and the outputs being different, or the inputs being different and the outputs being the same. The outputs can be the same, okay? Here is my metaphor that I use to sort of try and explain this, and I've used this with you and you and you before, and probably you because I've had you in class. If you're driving a car and you want that car to go forward, you can put it into drive, you can put it into first gear, you can put it into second, you can put it in third. So if I made a chart for that, it would look like this. It would say gear, and then it would say output. And if I put it in drive, first, second, or third, all of these would make the car go forward. Okay? If I put it in neutral, then it goes nowhere, and if I put it in reverse, then it goes in reverse. This is a function. Hang on just a second. What is not a function is if it looked like this. If sometimes when I put it into drive, it goes forward, and sometimes when I put it into drive, it goes into reverse. Okay? So if I have the same input and I get two different outputs, my car is broken. But if I can make the same output happen in a couple of different ways, that's okay. Sometimes. Yeah. Right. Yeah. Yes. You don't? Okay. Okay. Dylan stole yours. Dylan was never given one. Apparently you weren't either. All right, number 10, the size of the radius of a circle dependent on the area. Why did they change? Oh, did we skip 9? Oh, okay, sorry. Sorry. Okay, nope, let's not skip 9. Yeah, man. Okay, the volume of water in a given cylinder is dependent on the height of water in the cylinder. So they're kind of giving you the words right there. The volume is dependent. It depends on the height of the water, which is independent. The volume of water in a cylinder depends on the height of the water. So the volume is dependent. The height is independent. Function, yes or no? Can you have the same cylinder and then like the same height and have two different volumes? Same cylinder, same height, two different volumes. Same cylinder, so the width is the same, the radius is the same, circumference is the same cylinder. So like I'm going to take an empty soup can and pour it half full, measure the volume, dump the water out, and I'm going to pour it half full again. Is the volume always going to be the same if it's half full? Yes. So that means that this is, in fact, we got the phone. We got that phone. We got the phone. Number 6 was gorilla. Yeah. All right. Number 10, the size of the radius of a circle dependent on the area. So now we're flipping it around, I guess. And we're changing the area instead of the radius. So it says the size of the radius of the circle dependent on the area. That pretty much says the radius has to be, in this case, the dependent. And the area is the independent. Okay? Sir? Oh, you guys are. Function, yes or no? Yes. So, Talia, this is what we got going for this one. We got a circle, right? Yeah, no, I know. And like I said, don't sweat it too much because I won't test you on these, but it's just, we can just have this conversation. So here's the circle, and it has a radius that I'm not showing, but it's there. If I make the circle bigger, what happens to the radius? It also gets bigger. So in this case, you could say since we're starting with the circle, the size of the radius depends on the area of the circle. Okay? But then you could also, like we did in the other one, and that's again why I don't really enjoy this stuff, is you could say, if I just start with this as a, if I start with this as a radius, then my circle's that big. If I make the radius bigger, then my circle's that big. So that means in that case, the area depends on the radius. It's kind of like, bless you, it's kind of like what Matthew said with the gas. You can go to the pump and buy and fill up your tank with 15 gallons of gas, and then they'll tell you how much that costs. Or you can say, here's 20 bucks, and then you can go, so you can kind of flip it around a lot. Gesundheit. No, because the radius is the distance from the middle to the sides. So the circle gets bigger. I know what you're saying. The radius like would be the same segment, but they're not asking was the radius the same. They're asking is the length of the radius the same, and that would change. Okay. All right, students' letter grade dependent on the percent earned. So the percent is independent. Yeah, no doubt. And the grade is the dependent. The grade that you get depends on your percent in the class. Crazy stuff, huh? You're just joking. You don't know. Oh, now you get to punch me in the face. It's so fun. Function, yes or no? It is a function because every time I put in 90%, the computer says A minus. That would really tick you guys off. If Talia was like, I've got a 96%, but I've got a C, and then McKenna was like, well, I got a 96% and I have an A. And you'd be like, why is that? And I'd go, I don't know, Talia, that's just not a function. So you just get what you get, you know? Doesn't, yeah. You want to do that? Oh. No. You need to know. Every time the input is the same, you'll get the same grade. That has to be functional. All right, next one. The length of fence needed with respect to the amount of rectangular area to be enclosed. Well, let's talk about that in a second. Let's first identify the independent and the dependent variables.